Okay, I'm going to start this question by separating out the variables. I'm going to do that by taking the y down to this side, taking the dt up to this side. 1 over y dy is equal to sine t dt. And then at that point, I'll put in my integration signs and I will integrate both sides. If you integrate 1 over y, you get ln y. And if you integrate sine t, you get minus cos t. And I'm going to put the plus c on this side. At that point, I want to rearrange this to make y the subject. So I'm going to take e of both sides. E to the power of ln y is equal to e to the power of minus cos t plus c. This could be rewritten as e to the ln y is y, and e to the minus cos t plus c could be written as e to the minus cos t e to the c. If I multiply with the same base, I add the powers. E to the c itself is a constant, so I'm going to replace e to the c with a. Y is equal to a e to the minus cos t. Now, it tells us in the question that y equals 50 when t equals pi. So I'm going to replace y with 50. 50 is equal to a e to the minus cos, and t equals pi, so I'm going to put pi there. And then I'm going to use this to work out what a is equal to. Now, cos of pi is minus 1. Minus cos of pi would be 1. So we get 50 is equal to a e to the 1. So a is equal to 50 over e. Or another way of writing that would be 50 e to the minus 1. Replace the a here with 50e to the minus 1. Y equals 50e to the minus 1, e to the minus cos t. And when you're multiplying and you've got the same base, you add the powers. So this could be written as 50e to the minus 1 minus cos t. Just comparing that with what they've asked us to show here, they've taken a minus 1 outside as a factor, and if we do that, we'll get what they've got. 50 e to the minus 1 plus cos t. Okay. In part I, it says that we've got the height is 50 centimetres after pi seconds. Find the height after 6 seconds. So what we're going to do is replace t with 6. Y is equal to 50 e to the minus 1 plus cos of 6. And when you type that into your calculator, to the nearest centimetre, you get 7 centimetres. Find the second derivative and verify that the water reaches a maximum height after pi seconds. So the first thing I'm going to do is I'm going to work out what the second derivative is. Just to remind you from earlier, dy by dt is equal to y sine t. Now, to find the second derivative, I need to differentiate that again, and I'm going to do that using the product rule. I'm going to say let u be equal to y, and let v be equal to sine t. Du by dt would be equal to, if you differentiate y, you get 1, but then you'd have to multiply that by dy by dt, which would just give you dy by dt. And dv by dt, if you differentiate sine, you get cos t. Put that into the product rule, and you get that the second derivative is equal to this multiplied by this, y cos t, plus this multiplied by this, dy by dt sine t. It says verify the water reaches a maximum height after pi seconds. So the first thing I'd want to do is verify that at y equals 50 and t equals pi, you end up with a stationary point. So I'm going to substitute 50 and pi in to see what dy by dt is. Dy by dt is equal to 50 sine pi. Sine of pi is 0, so dy by dt would be equal to 0. Therefore, a stationary point. Next, I would just need to confirm that this stationary point is indeed a maximum, which would mean that the value of the second derivative is negative. So I'm going to substitute in the values that I know. Y is equal to 50, t is equal to pi, dy by dt is equal to 0. Second derivative would be equal to 50 cos pi. This whole term would become 0, and so that gives me minus 50, which is a negative number, which means it is a maximum point.